Hi there and welcome to Mr. Arnold's Maths. In this video we're going to look at the AQA's new certificate. It's a level 2 certificate in further maths for GCSE and I'm going to look at practice paper set 1, paper 1. So let's just jump right in and we'll crack on with this paper. Alright, question 1. We're told that x is an integer such that 6 is less than 3x, which is less than or equal to 20. And we're asked to write down all the different values of x. Now the important factor here is it's an integer, which means it must be a positive or negative whole number, and it must lie within this criteria. Now we're asked about x. Here it gives me 3x, so I'm going to divide everything by 3 and get a slightly different range. So dividing by 3 we get 2 is less than or equal to x, which is less than or equal to 6 2/3, or 6.6 recurring if you like. So what numbers lie between 2 and 6 2/3 and are positive whole numbers? Well, it must be 3, 4, 5 and 6. That's question 1 in the bag. Right, 1b. So we're told that minus 1 is less than n, which is less than 2, and we're asked to choose a value for n such that n squared is greater than 1. I've selected 1.5, and pretty much any value that's bigger than 1, when you square it, it's going to be bigger than 1. So any number that's greater than 1 but less than 2. Next one, 1 over n is greater than 1. So I need to choose a value for 1 over n. In this case, I chose 0.5. Any number that's less than 1 but greater than 0, so any number that's actually less than 1 but greater than 0 will actually give us the solution to this one. 1 divided by a half is actually 2, and 2 is greater than 1, so that's why that works. And the next one, any number that's between minus 1 and 0 will give us a correct answer here. So I chose minus 0.5. 1 minus 0.5 is the same as 1 plus 0.5, which is indeed greater than 1. And that's that question. Right, question 2. We're given a function and it's defined as such here. And we're asked to draw the graph of the function, and then we're asked to work out the range. So let's have a look at what the function states. It says that f of x is equal to 3 between 0 and 2. That means, let me just get the straight line tool out, that between 0 and 2, f of x is always 3. So between 0 and 2, f of x is 3. And then between 2 and 4, f of x is equal to x plus 1. Well, if x was 2, f of x would be 2 plus 1, which is 3. If x was 3, which is still within this criteria, if x was 3, f of x would be 4, because it's 3 plus 1 would be 4. So that means if if x was 3, f of x would be 4. If x was 4, f of x would be 5. So we go up as far as there. Now, if x was 4, that means f of x would be 5. So that satisfies that criteria. If x was 5, so still in here, if x was 5, f of x would be 4. So we're coming back down again. F of x would be 4. And as you'll see, the graph actually goes right the way down to there. Just a quick check on that. If if x was 9, f of x would be 0. If x was 8, f of x would be 1. So you just choose a value for x that falls within those criteria, substitute it in there, and that tells you where the graph passes through. Okay, so we're asked to write down the range of f of x, and if you know from your statistics, the range is generally the highest value minus the lowest value. Well, the highest value this graph takes is 5, the lowest value is 0, 5 take away 0 is 5, so that's the range of f of x. On we go. All right, question 3. We're given a diagram with a tree and a mast, and basically we're asked, can the mast hit the tree if it falls over? So essentially, I need to know how tall this mast is. I'm going to call it M. And I need to see if this mast, well, if it falls over that way, is it going to be the distance, which is this, the distance is 35 meters. So I need to see, is that mast at least 35 meters tall? If it is, it could hit the tree. So what I've done is I've called the mast M, and I'm calling this angle here theta. And if we use our trig functions, we know that the tan of the angle theta will equal 18 over 30. 18 over 30. Okay, the opposite over the adjacent. But similarly, tan of theta should be equal to m, the opposite, over the adjacent, which is 65. Now, these two ratios are exactly the same. They're the same. So that means that I can equate both of these. So I can say 18 over 30 should be equal to m over 65. And then solving for m, let's see, we'll just do this in two stages. M should be equal to, let me see, 65 times by 18 over 30. And cancelling this down, 6 goes into this 3 times, 6 goes into this 5 times, 5 cancels in with this, and we get 13. So we get 13 times 3, which is, beg your pardon, 39. So the mast is 39 meters high. That means, yes, it could hit the tree. Job done. On we go. Question 4. So we're given a third question. We're asked to simplify this fully. Let's just take a look at the root 48. Well, root 48 is the same as the square root of 4 multiplied by 12, which hopefully, if you understand your thirds, that's the same as 2 root 12. So root 48 is the same as 2 root 12. So we end up with root 12 divided by 2 root 12. Root 12 into root 12 goes once. So we end up with, this simplified fully is a half. Nice handy 3 marks there. This one we're asked to expand and simplify this, or to write down the value basically. You can multiply everything out. I'm not going to bother to do that. I'm actually going to use a little trick. I can see that we have a negative sign here and a positive sign here, so we can use the fact that the difference of two squares, a squared minus b squared, equals a minus b times a plus b. And if you have a look, if I let a equal root 6 and b equal root 2, I can use this result. So, well, a squared would be root 6 squared, which is simply 6. B squared would be root 2 squared, which is simply 2. And 6 minus 2 is 4. Now, as I said, you can multiply this out using FOIL or whatever method you know for expanding two brackets and simplify. You should get the same answer. That's just a quick way of doing it. Alright, question 5. We're asked to sketch the graphs. Okay, well, looking at this, x squared plus y squared equals 4. Hopefully you know from your coordinate geometry of the circle that this is a circle with center 0, 0, and radius of 2. How do I know the radius is 2? Well, the general formula is x squared plus y squared equals r squared. r squared is 4. That means r must be 2. So I'm going to draw a circle with radius 2. I'm going to use my circle tool. Hopefully this works out nicely. That's not too shabby. Right, so we have a circle of radius 2, and I have to draw in y equals 2x plus 1, which is a line, a straight line graph with gradient 2, and it cuts the y-axis at 1. So the y-intercept is 1, the gradient is 2, and we can just draw that in. Okay, so we've drawn we've sketched our graph of the circle and the line, and now we're asked to shade the region that satisfies both of the inequalities. So it says here x squared plus y squared is less than or equal to 4. Well, if it's less than or equal to the radius squared, that means it's inside the circle. Inside the circle, okay, because it's less than or equal to the radius. So that tells me I'm going to shade inside the circle, and it says and where y is greater than or equal to 2x plus 1, that means I'm going to shade above the line. Okay, so we're shading inside the circle and above the line, which is all this region in here. And there's your mark for that question. Okay, question 6. So we're told that sine of theta is 3 over 5, and we're asked to work out two possible values of cosine theta. Now, I'm just going to sketch a right angle triangle really quickly. And if we have an angle theta, and we're told sine theta equals 3 over 5. Okay, hopefully you remember from SOHCAHTOA or whatever way you remember your trig functions that sine of an angle is the opposite over the hypotenuse. So the opposite in this case must be 3, the hypotenuse must be 5, and if you know your Pythagorean triples, you can work out that this is 4. It's the general 3, 4, 5 triangle. There's many other Pythagorean triples. Another one is 5, 12, 13. You can draw a right angle triangle using those dimensions. That's a fairly straightforward one. Most of us should know that. If you don't know it, you can always use Pythagoras' theorem anyway to work it out. So you'd have 3 squared plus the adjacent squared must be equal to 5 squared. A squared must be equal to 16. That means A must be equal to 4. Now, it actually asks us for two possible values of cosine theta. Cosine, by the way, now that I know my triangle, cosine theta is the adjacent over hypotenuse, which is 4 over 5. We're asked for two possible values. Well, hopefully you know that when you take the square root of something, you can actually have a positive and a negative answer. So A could be plus or minus 4. So the answer will be 4 over 5 and minus 4 over 5. Now, you might wonder, how can you have a negative length in the triangle? You can't essentially, but that is a question for another day. The answer here is 4 over 5 and minus 4 over 5. Right, we're given the equation of three lines, and we're asked, do they all meet at a common point? We're asked to show how we decide. Now, generally, where two lines meet, we solve that using a simultaneous equation, but this time we have three lines. So what I did was I started by labeling all the lines. I call that 1, call this equation 2, and that can be equation 3. And then I chose two of these lines, solve the simultaneous equation, and then substitute the answer back into the other line and see if it works. Right, a lot of talking there. Let's just check out how this works. So I'm going to do equation 3, and I'm going to take away equation 1. So let's write down equation 3 again. You had y equals 2x minus 16, and equation 1 is y equals a half x plus 11. Right, so we're doing equation 3, take away equation 1. So the y's cancel out, we get 0. 2x take away a half x is 3 over 2x, or 1.5x if you like, and minus 16 take away 11 is minus 27. Right, so we solve for x, we get 3 over 2x equals 27. That means 3x must be equal to 2 times 27, which is 54, which means x must be equal to 54 divided by 3. That goes in once, and 18. So x is 18, and I'm going to substitute x equal to 18 into one of the equations. I'm going to choose equation 3 because, well, it's a little bit easier than these two. So subbing it into equation 3, we get y equals 2 times 18, which is 36, take away 16. So y must be 20. Right, now I got to check. Okay, so we got a value for x, we got a value for y that satisfies this equation and this equation. And I'm going to check now, check that this solution also satisfies equation 2. Right, so substituting x equal to 18 and y equal to 20 in here, we get 20 should be equal to 1/3 times by x, which is 18, plus 14. So 20 should be equal to 6 plus 14, and 6 plus 14 is 20. So yes, that works. So yes, they all meet at the point 18, 20. Nice, handy 5-mark question. Okay, question 8. So we're given A, B, C, which are points on a circle with center O, and we're told that BAC equals OBC equals X. So basically you're told that this angle is the same as this angle. And we're asked to prove that BOC is 90 degrees. So we want to work out this angle here. Well, if you know your circle theorems, you should know that BOC must be equal to 2x. Why? Because the angle at the center of a circle is twice the angle at the circumference. So I'm just going to write angle at center. Angle at center is 2 times is twice angle at circumference. Okay, so that's a start. So that must be 2x. Also, if you have a look, BO and CO are both radii, which means that this is the same as this, which makes this triangle BOC must be isosceles. If this is isosceles, that means that this angle here must be x. Okay, so BCO, angle BCO must be equal to x. Isosceles triangle. Okay, and we also know that the angles in a triangle all add up to 180, which means that 2x plus x plus x must be equal to 180. So altogether we have 4x must be equal to 180, which means 2x is equal to 90. And it's proved without doubt. So the angle BOC has been proven to be 90 degrees. There's your 40 marks. Okay, 40 marks. Question 9. A right circular cone is being filled with water, and we're told the volume of water is y centimeters cubed when the depth of water is 3x centimeters and the radius of the surface is x centimeters. And we're asked to show that y equals pi x cubed. Now what you're going to need here is your formula, which is in the front of your booklet, and we're looking for the volume of a cone. The volume of a cone is 1/3 times pi times r squared times h. Right, so going back to our diagram, all we got to do is substitute in. So the volume is going to be equal to 1/3 times by, well, let's get rid of that, 1/3 times by pi times by the radius which is x, times by x squared times by h, which is 3x. Okay, well, 1/3 times by 3 gives you 1, and x squared times by x is x cubed. So that means the volume equals pi x cubed. And the volume, we're told, is y. So y equals pi x cubed, a nice easy mark. Okay, now we're asked to work out dy dx and give your answer in terms of pi. So we got to differentiate this. So we know y equals pi x cubed, y equals pi x cubed. That means dy dx equals, you take the power, you multiply by the coefficient of x and drop your power by 1. So power multiplied by the coefficient, remember, pi is a constant, so it's going to be 3 times pi times x and drop your power by 1, 3 pi x squared. Done. 9c, we're asked to work out the rate of change of y with respect to x when x is equal to 5. So what I'm going to do is, we're going to evaluate, we're going to do dy dx, and we're going to evaluate it at x equal to 5. So dy dx when x is equal to 5, we get 3 times pi times 5 squared, which equals, well, 5 squared is 25. 25 times 3 is 75 pi. Another handy 2 marks if you understand your calculus. Okay, so on to question 10. And we're asked to simplify fully this nasty looking piece of algebra, really. Now, before we dive in with this question, it's always good to just stop for a second and have a quick look and see if you can spot anything. If you look at the top expression, hopefully you can recognize that that's a quadratic. Underneath, we have the difference of two squares, and here we have an expression that looks like it can be factorized. So we can actually factorize 3 of these expressions here. So before we actually tackle the question, let's factorize. 3x squared minus x minus 14, when we factorize that, we get 3x minus 7 and x plus 2. Now, I'm not going to go into how I factorize that. You should be able to do that yourself. 9x squared minus 4, when factorized using the difference of two squares, is 3x minus 2 and 3x plus 2. And this expression here, 3x squared plus 2x, when factorized, factor out your x, you get 3x plus 2. Okay, so we factorized 3 of the expressions, cannot factorize that one there, so let's start to write it down. So the top expression is 3x minus 7 times by x plus 2, underneath we've got 3x minus 2 times by 3x plus 2. Now, before I write down the other one, notice here that it's divided by a fraction. So we've got a fraction divided by a fraction. And if you think to what you should do when you have a problem like this, but using numbers, normally what you do is you flip the second fraction upside down and you multiply. So that's exactly what I'm going to do here. I'm going to flip the second one and multiply instead. So on top, we end up with x times 3x plus 2. And below, we end up with x plus 2. So we're going to multiply these two fractions together. And when you multiply fractions, you always just do the top multiplied by the top and the bottom multiplied by the bottom. So when we do that, I'm just going to write this slightly different. We end up with, so the whole lot equals x times 3x plus 2 times 3x minus 7 times x plus 2. And underneath we get 3x minus 2 times by 3x plus 2 times by x plus 2. So I've just multiplied top by top. Didn't multiply anything out, but basically I've just stuck all the terms together. Okay, so let's have a look and see if anything will cancel. Well, my x plus 2 will cancel with my x plus 2, and the 3x plus 2 will cancel with the 3x plus 2. Oh, how nice. So what are we left with? On top we have x times 3x minus 7, and underneath we still have 3x minus 2. And that is it. You do not need to multiply this out. It doesn't simplify the problem any further, really. So you'll get full marks if you go as far as there. Okay, question 11. Really getting tough now. So we're asked to show that the tangents to the curve y equals all of this at x equal to 1 and x equals minus 3 are parallel. Okay, when you see that phrase, tangents to the curve, you should always think calculus, think derivatives. So the first thing I'm going to do is I'm going to take the derivative of the function here. So we have y equals that. So that means dy dx, take the derivative of y with respect to x, gives me 3x squared plus 6x plus 3. Okay, so the gradient function of the tangents to the curve is this. Okay, so remember that's the gradient of the tangent to the curve. And I want to know if at x equal to 1 and x equal to minus 3 they're parallel. Well, when two gradients are parallel, or two lines are parallel, that means the gradients are the same. So to show that two tangents are parallel, well, a tangent is a line. I'm going to show that the gradient of the tangents are the same. So I'm going to evaluate dy dx. I'm going to evaluate, first of all, at x equal to 1. Right, so we get 3 times 1 squared plus 6 times 1 plus 3. So we end up with 3 plus 6 plus 3, which is 12. Right, let's do the second one, dy dx. And I'm going to evaluate that now at x equal to minus 3. So evaluating at x equal to minus 3. That gives me 3 times minus 3 squared plus 6 times minus 3 plus 3. And we get, let me see, minus 3 squared is 9, 9 times 3 is 27, and minus 18 plus 3, and 27 take away 18 plus 3 is 12. So you'll notice that the gradients are the same. Same gradient, therefore parallel. Same gradient, therefore parallel. God, my writing is shocking today. On we go. Question 12, we're asked to make x the subject of the formula. Now this one looks nasty, but again, if you're any good with your algebra, you should be able to tackle this one. Right, I do not like this y and x underneath the line, so as denominators, I want to get rid of that. So I'm going to multiply everything by the LCM of the denominators, and the LCM of y, x, and 3, the lowest common multiple, is 3xy. Okay, so literally just multiply all these together. So if we write down this again and leave a little bit of space, hopefully you can see clearly what's going on. So you get 12y, or 12 over y, equals 4 over x. I'm just going to leave a little space so you can see what I'm going to do, over 1 over 3. And I'm going to multiply absolutely everything by this. So I'm multiplying that by 3xy, multiply that by 3xy, multiply that by 3xy. Right, so we can cancel out now. The y cancels out with the y, the x cancels out with the x, and the 3 cancels out with the 3. And what are we left with? We got 12 times 3 times x, which is 36x, must be equal to 12y minus xy. Okay, and looking to make x the subject of the formula, so take anything with an x over to the left hand side. So we get 36x plus xy, so I'm adding xy to both sides, must be equal to 12y. Have a look at this expression here. I can factor out the x, so we get x into 36 plus y equals 12y, and lo and behold, x must be equal to, dividing both sides by 36 plus y, must be equal to 12y divided by 36 plus y. So dividing both sides by 36 plus y. And that's the job done. Right, question 13. We're given a identity here, and we're asked to work out the 3 linear factors of that cubic expression. Right, one way of doing this question, the first time I saw this question, what I did was I expanded everything out and we solved for coefficients of a and b. There's actually a little bit of a quicker way of doing it. If you look at this, x squared minus a squared, that's the difference of two squares. So taking a look at this part here, well, that's simply x minus a times x plus a times x plus b. Okay, and if you have a look at the negative 18, well, that negative 18 is going to come from multiplying all the constants for each linear factor. And the constant for each linear factor is the a here, and the b. So when I multiply minus a by a and multiply that by b, that will give me the negative 18. It must be equal to negative 18. So I need to find a term, tidying up, we get minus a squared b must be equal to minus 18. So a squared b must be equal to 18. And can I break 18 into two numbers such that one number is a square number and one number is not? Well, if you think of the factors of 18, let's come down here. Factors of 18 are 1 and 18. No good. What else have we got? We've got 6 and 3. No good. However, 9 and 2. 9 is a square number, 2 is not. So 9 and 2 work beautifully here. So if a squared was 9, that means a equals plus or minus 3, and b must be equal to 2. And that's a fairly quick way of doing that question. So the 3 linear factors are x minus 3, x plus 3, and x plus 2. And if you do have the time of the exam, you could always expand this expression out and check and see that you get this. I'm almost certain that you will. Okay, question 14, matrices. So we're given the unit square OABC, and we're asked to draw and label OA-B-C-, which is the image after it's been transformed by this matrix. Now I'm going to show you the really long way of doing this, which is basically to take this matrix here, 0, minus 1, minus 1, 0, and multiply it by a matrix that defines this square, which is literally every coordinate pair written as a vector. So we've got O is 0, 0, A is 1, 0, B is 1, 1, and C is 0, 1. Okay, so we bit of matrix multiplication here. That's a 2 by 2 matrix. That's a 2 by 4 matrix. So we can multiply them because these numbers are the same. So when you multiply that out, you're going to get 0, 0, 0 minus 1, minus 1, minus 1, and minus 1, 0. And that tells me the coordinates of the corresponding parts. So that's still O, that's going to be A dash, that's going to be B dash, and that's going to be C dash. So let's just check and see what happens. 0, 0 is there. A dash 0 minus 1, which is there. B dash, which is minus 1 minus 1. And C dash, which is minus 1, 0. So our square is here. Right, so O, A dash, B dash, C dash. Okay, so that's the long way of doing that question. There's actually a slightly shorter way. If you look at this, this is your I component, and this is your j component. Okay, now in the question, that was your I component there, and that was your j component there. Now the I component is, it was 1, 0. So that's the I component. It was 1, 0, and the j component was 0, 1. And what's happened? Well, the I component has now become 0 minus 1, so it's gone to here. Let me just change color. That was the I component, and now it's 0 minus 1. The j component was 0, 1, which was here. It's now minus 1, 0. So minus 1, 0, which is there. So if you think about it, it's actually been transformed by a reflection in the line y equals minus x. So it's been a reflection through there. This has been mapped to here, this has been mapped to here, this has been mapped to here, and O stayed in the same place. So if you're not sure about that, just stick with the matrix multiplication method. That's just a slightly different way of understanding that question. Right, so next part, 14b. We're given the unit square again, and we're told that it's transformed by a reflection in the line y equals x, followed by an enlargement about the origin with scale factor 2, and we're asked for the matrix of the combined transformation. Right, so this is, it's been reflected through that line to start. So I need to know what matrix will describe the line y equals x. So the I component was 1, 0, and the j component, the I component, let's write it up here, the I component was 1, 0, and the j component was 0, 1. Now when it gets reflected, the I component is going to go up here. So the I component is actually going to be 0, 1, and the j component is going to come down here. So the j component is going to be 1, 0. So that is the matrix that defines y equals x. So it's going to be 0, 1, 1, 0. And for a scale factor 2, well, that's simply twice the identity matrix. So it's going to be 2, 0, 0, 2. And we're asked to give the matrix of the combined transformation. When you're doing combinations, you always work from last to first, so in that order. So the last matrix is actually 2, 0, 0, 2. That was the last thing that happened. So I'm going to multiply that by the first thing that happened. And I'll take a bit more time with this multiplication. 2 times 0 is 0. 0 times 1 is 0. So the first part is 0. 0 times 0 is 0. 2 times 1 is 2. Add them together. 2 times 1 is 2. 0 times 0 is 0. 2 and 0 is 2. And then 0 times 1 is 0, and 2 times 0 is 0. Add the two together, you get 0. And that is your answer. So that's the matrix of the combined transformation. Right, question 15. We're asked to use the equilateral triangle to show that cosine 60 degrees is 1/2. Now, I did this question by using the cosine rule. The cosine rule states that a squared equals b squared plus c squared minus 2bc cosine a. If I call that a, I should be able to fill in these. Just to let you know as well, it's an equilateral triangle, which means that a must be 60 degrees. So we get 2 squared equals 2 squared plus 2 squared minus 2 times 2 times 2, so minus 8 cosine 60. Okay, let's tidy up a little bit. 8 cosine 60. So I'm bringing the 8 cosine 60 over this side. 8 cosine 60 must be equal to 2 squared plus 2 squared, and then take away the 2 squared. 4 plus 4 is 8. 8 take away 4 is 4. That means cosine 60 must be equal to 4 divided by 8. So cosine 60 is equal to half. Now, if you want, you can take a bit more time with the calculation here. I have kind of rushed it, but yeah, it's just some basic algebra. And the final question, we're asked to use the cosine rule to show that x equals 4 plus 2 root 7. Now, this was a doozy of a question. Right, let's get straight to it. We know from the cosine rule that I'm going to call that a. So 2x plus 1 squared must be equal to x plus 3 squared plus 2x plus 4 squared minus 2 times x plus 3 times by 2x plus 4 times by cosine 60. Right, now remember, we've already shown that cosine 60 is a half. Okay, so I'm going to expand this out. When I expand that out, again, I'm going to do it quickly. We get 4x squared plus 4x plus 1. And when we expand this bit out, we get x squared plus 6x plus 9. And then expanding this out, we get 4x squared plus 16x plus 16. And cosine 60 is a half, so it's going to be all of this expression. I'll just put it in blue brackets. All of this has to be expanded out. Now 2 times a half, because that's a half, 2 times a half is 1. So I'm really only concerned with this bit here. So remember, it's take away. Okay, put up brackets just to protect what's going on. When you expand this out, you get 2x squared plus 10x plus 12. Okay, it's really important that you put the brackets after this negative sign here, because the negative sign takes effect on everything in here. Right, so now that we've done that, I'm going to leave my left hand side alone. So the left hand side, LHS, must be equal to, and let's tidy up everything in here. X squared plus 4x squared is 5x squared. 5x squared take away 2x squared is 3x squared. Alright, I'm going to tick those off as I do them. So that's taken care of. Right, 6x plus 16x is 22x, and 22x take away 10x is 12x. So that's those taken care of. And finally the constants, 9 plus 26, or 9 plus 16 is 25. 25 take away 12 is 13. Okay, so let's bring everything to one side. So I'm going to take all of this over to the left hand side and simplify. I'm going to do it all in one go. 4x take away 3x is x squared. 4x take away 12x is minus 8x, and 1 take away 13 is minus 12, and all of that is equal to 0. Now if you look at this closely, you'll see that you cannot factorize it simply, and also the answer that we're told to give should give you a hint of what we need to do. It's quadratic formula time. So substituting into the quadratic formula, we get x must be equal to minus b, so minus minus 8 is 8, plus or minus the square root of the following. B squared, which is going to be 64, minus 4 times by a times by c. And that's all divided by 2a. So we get x equals 8 plus or minus square root 64. Okay, let me see. Minus 4 times minus 12 is plus 48. And 48 plus 64 is 112. Okay, and that's all divided by 2. Now 112, let's do this over the side. 112 is actually equal to 4, is the same as 4 times 28. So 4 times 28, which is equal to root 4 times by root 28, is equal to 2 root 28. Root 28 actually, let's do that here. Root 28 is equal to 4 times 7. So root 28 is equal to root 4 times 7, which equals 2 root 7. So we got 2 times 2 root 7, which is equal to 4 root 7. 4 root 7. So we get 8 plus or minus 4 root 7 all over 2. So x must be equal to, dividing both by 2, you get 4 plus or minus root 7. Now, the reason why I chose to ignore the minus, well, we're not interested in that. It just asked me about showing that x equals 4 plus 2 root 7. Sorry, that should be 4 plus 2 root 7. And that's it. Okay, tricky enough paper there, guys. Hope you enjoyed the video. If you have any questions or comments, please do feel free to comment, and I will talk to you again sometime. Best of luck in the exams, and take it easy.